Hello to all the amazing first grade students out there. Welcome back to this week's first grade STEM lesson. I hope you really love it. It is called After the Fall. And as you can see, there's some clues on the first page here. This thing here is an egg, and he's sitting on a wall. Does that remind you of any stories that you know of? Maybe Humpty Dumpty? Well, I hope it did, because today we are going to we're going to listen to a story called After the Fall. It's about Humpty Dumpty, and within that story, there is a connection to our STEM lesson today, which is all about paper gliders, or better known as paper airplanes. And there's this little clue here, right here. So somewhere within the story that we're going to read about Humpty Dumpty is there's going to be something about paper airplanes. Okay, so look for it when we read it. So this is the story that we're going to listen to first. It's called After the Fall: How Humpty Dumpty Got Back Up Again. Okay, and I want you to pay really close attention to this story. Because after this read aloud, we're going to do some really cool STEM learning. We're going to learn about the science of flying. We are going to learn about some really, really important vocabulary words that are connected to airplane flight. And we're going to watch a short video on how to make a really cool paper airplane if you need that support, because some people don't have as much experience with making paper airplanes. And then we're going to do some experimenting on how we can make our paper airplane fly as far as possible. So here we go. The 4 vocabulary words that we're going to learn before we hear the story are admit. You can see on a shirt right here, it says honesty. So when you admit something, it means that it is to tell the truth about something. So that's why a shirt says honesty, because when you admit something, you tell the truth. Even if it's scary, or you'll get in trouble after you tell the truth, you still have to admit that thing. The next thing is heights, a high place. And if you know the story of Humpty Dumpty, you know that he goes up in a really high place and he falls off. Uh-oh. And the next one is bandage, a cloth that protects an injury, or another word for it is a Band-Aid. Bandage, Band-Aid. And the last word is terrified, which means extremely scared. And you see this girl right here? Wow, she really is terrified. I wonder how that word is connected to our story. Let's find out by watching this video. And as you can see, the story is After the Fall: How Humpty Dumpty Got Back Up Again by Dan Santat.
Welcome to Baby Story Time. Do you want to read this book with me? Don't forget to click the subscribe button for more. After the Fall: How Humpty Dumpty Got Back Up Again. A story by Dan Santat. My name is Humpty Dumpty. This was my favorite spot, high up on the wall. I know it's an odd place for an egg to be, but I loved being close to the birds. Then one day I fell. I'm sort of famous for that part. Folks called it the Great Fall, which sounds a little grand. It was just an accident, but it changed my life. Fortunately, all the king's men managed to put me back together. Well, most of me. There were some parts that couldn't be healed with bandages and glue. After that day, I became afraid of heights. I was so scared that it kept me from enjoying some of my favorite things. I walked past the wall every day, and I would think about climbing that ladder again. I really miss the birds and being high above the city, but I could never do it because I knew that accidents can happen. I eventually settled for watching the birds from the ground. It wasn't the same, but it was better than nothing. Then one day, an idea flew by. Making planes was harder than I thought. It was easy to get cuts and scratches, but day after day, I kept trying and trying until I got it just right. My plane was perfect and it flew like nothing could stop it. I hadn't felt that happy in a long time. It wasn't the same as being up in the sky with the birds, but it was close enough. Unfortunately, accidents happen. They always do. I almost walked away again, but then I thought about all the time I'd spent working on my plane and all the other things I'd missed. I decided I was going to climb that wall, but the higher I got, the more nervous I felt. I didn't want to admit it. I was terrified. I didn't look up. I didn't look down. I just kept climbing, one step at a time, until I was no longer afraid. Maybe now you won't think of me as that egg who is famous for falling. Hopefully, you'll remember me as the egg who got back up and learned how to fly.
So as it says here, life begins when you get back up. And what I loved about this video is it wasn't the falling part and it wasn't when Humpty Dumpty got fixed by all the king's men that he learned to show perseverance and to not give up. It was the part where he was making the paper airplane. He was not very good at it at the beginning, but what did he say in the book? It said he kept trying and learning and making mistakes and learning from those mistakes, and then he would try again and again. If you see on his desk, there were many crumpled papers all over his desk. So he had to try and try and try again, and then he finally got it. That was where he learned the skill of perseverance, not giving up. And that helped him later in the story when he climbed the ladder. So that's what we're going to do today for STEM. And before we get to the activity part, we have to do some learning. And what I'm going to do here is we're going to watch a video that's all about the forces of flight. Have you ever looked up into the sky, seen a fighter jet or a big passenger airplane, and just wondered, how does something that big and heavy get up in the sky? Well, you are going to find out in this video right here.
Hey guys, John from flyatmikealpha.com, and today we're talking about the four forces of flight, how these gigantic machines get off the ground. So how does an airplane actually get into the air? What forces are acting upon it when it's flying through the air? So there's four fundamental forces. We'll focus on each one. So we see this gigantic Boeing 747 lift off the ground. There's four fundamental things that are acting on it, the same as the four forces that are acting upon our little Piper Cherokee here as it rolls down the runway and takes off. We'll get right to it. So let's define the four forces that are always acting upon an airplane, whether it's taking off, flying through the air, or coming in for a land. The four forces are thrust, which comes from the engines, the propeller or the jet engine, drag, that tries to slow the airplane down and fights against those engines, the lift, keeping the airplane in the air, what's holding it up, the wings, and the weight of the airplane. Notice we don't say gravity, but we say weight of the airplane acting in the opposite direction, fighting against that lift, trying to pull the airplane down towards the ground. Now, it's important to note that these forces don't ever bend or change the angle that they're pulling in. Thrust will always directly oppose drag, and lift will always directly oppose weight. So regardless of the bank or the pitch of the aircraft, you're always going to have lift directly opposing weight and thrust directly opposing drag. Now let's take a look at these forces as they act upon the airplane as we're flying along straight and level here, say at 100 miles an hour. We have our four forces all in equilibrium. The airplane's level at 1,000 feet and 100 miles an hour. And then we accelerate the airplane, say to 150 miles per hour. And as we speed it up, as we accelerate it, then we must have more thrust than drag as it accelerates. Now, once we get to, say, 150 miles per hour and we're stable again at cruising along at 150, then we're back to the four forces being in equilibrium. Lift equals weight, and thrust is equaling drag. We're stable at 150 miles per hour and 1,000 feet. Now let's go ahead and look at four forces when we're climbing or descending. And so here's the tricky part. If we take our airplane and we want to start climbing, say we're at 1,000 feet, we're going to go ahead and go up to 2,000 feet. Then we need to accelerate upward, generate more lift than weight, and the airplane starts accelerating upward. Now, once we get to, say, 500 feet per minute up, weight and lift will then equal again, and we'll continue to climb upward. So we are climbing, getting higher, but we're not accelerating upward. So the four forces are always equal when you're in unaccelerated flight. Unaccelerated. So if you're stable at 100 miles per hour and 500 feet a minute going up, then the four forces are equal. Lift equals weight, thrust equals drag. If you're decelerating, accelerating, or if you go ahead and stop climbing from, say, 500 feet per minute and level off, then momentarily your lift will be less than weight so that you can decelerate your upward motion and level off at, say, 2,000 feet here. And then you resume level unaccelerated flight and the four forces go back to being equal. So as we look at our Piper Cherokee here, rolling down the runway, as we accelerate down the runway, we have more thrust than drag. The airplane's increasing its speed, and we don't quite have enough lift to get off the ground, so we have less lift than weight until eventually we have enough airspeed to generate enough lift. We get more lift than weight, and the aircraft leaves the ground and starts climbing upward. And then eventually, once we're established in climbing flight, the four forces are equal. We're stable at 85 miles per hour, and we're climbing at, say, 500 feet per minute, and everything's stable. The four forces are equal as we're climbing upward. Now, even as we approach to land here, the four forces are actually equal. We're descending at 500 feet per minute. Our airspeed's stable at 80 miles per hour. As we come down to get closer to the ground, we'll start to ease back on the controls. That increases our lift on the wings, decelerating us as we come down to the ground to try to level off close to the ground. It also increases drag, which makes the airspeed slow, so that we touch down right about 60 miles per hour and as close to a zero rate feet per minute descent as possible. As we roll out here, drag is greater than thrust because the power is at idle. We're applying brakes, and the aircraft slows down. It generates less and less lift and settles down onto the wheels and stays nice and stable on the ground. What you ultimately need to remember here is that there's four forces that act upon every airplane flying through the air: lift, weight, thrust, and drag. And those four forces are often equal unless the airplane is accelerating, either up, down, or forwards or backwards. If it's an unaccelerated flight, all four forces are equal, even if it's climbing or descending. Hope you found this helpful. Be sure to check out some of our other YouTube videos down here below. Check out our Patreon page, how we fund all these videos, and make sure you subscribe to our YouTube channel so you keep up with all our latest episodes. If you have any questions at all, leave them in the comments below, and we'll be sure to get back to you as soon as possible. Remember, if you can't fly every day, then fly at MikeAlpha.com. We'll see y'all next time.
All right. So, like it says here, thrust is what makes the airplane accelerate forward. Drag is what slows the airplane down. Lift is when the airplane goes up, and weight is when the airplane goes down towards the ground. And as it says here, so again, lift right here is the force of flight that pushes an object forward. Drag, force. Whoops, these are backwards. So Thrust is the force of flight that pushes an object forward. Lift, force that pushes an object upward. Drag, force on an object in the air that reduces forward motion. Gravity, force of attraction of objects to the center of the earth. All right. So here is your STEM challenge activity for the day. So I'm going to introduce it, but we're not going to start building yet. It's a bird, it's a plane. Yes, it is. It's an airplane. As you can see, here is Humpty Dumpty working super hard. As I mentioned earlier, there's all his crumpled up pieces of paper that his failed attempts, but he learned from it each time. So my question for you is, can you create a paper airplane or a paper glider that will fly the farthest distance? You may also decorate your airplane to look like a bird, just like Humpty Dumpty did in the book. Okay, so the materials that you are going to need are paper, crayons or markers, a yardstick or a meter stick with centimeters, or a measuring tape. If you don't know what a measuring tape is, you can ask your mom or your dad if they have a measuring tape that you can borrow, because I feel like after you watch the video that I'm going to show next, you're really going to throw that airplane really far. But before I show the video, I have 4 more words I want to introduce to you. Again, one of them is a repeat, gravity, and that is the force that pulls everything towards the center of the earth. So when an apple breaks from the tree branch, it falls down, not to the left or the right or up, unless there's wind. It falls straight down to the ground because the center of the earth is pulling everything towards the ground. The next one, the opposite of gravity, is lift, and that is to raise from a lower to a higher position. So when the airplane takes off and it goes up into the air, that is lift. And when it does that, it uses the wing or wings, because airplanes have 2. And a wing is an object that sticks out to each side and helps lift an object off the ground. A bird has wings, airplanes have wings, paper airplanes also make sure that your paper airplane has wings as well. The last one is vertical stabilizer, and that is this big fin that is on the back end of the airplane. Okay, there's also little fins that stick out to the side, but this one here is the vertical stabilizer, because vertical is up and down, and that's why it's called that. And that is the tail fin of an airplane. It keeps the airplane flying straight. Okay, so the vertical stabilizer. If you would like to add a vertical stabilizer onto your paper airplane, go for it. You can make it look just like a real airplane. So next, this is for those that, for the kids that maybe don't have as much experience making a paper airplane, but it's also for those that do, because you might learn something from this video that will help you, even though you already have a lot of experience making paper airplanes. So here we go.
Hey guys, Squeaks and I are making paper airplanes. We're trying to make different kinds and see how high they fly. You want to join us? Just grab some paper and we'll make one together. Let's start by folding the paper in half.
Okay. Now, before I continue with the video, I want to remind you that at any point in this presentation, please feel free to pause the video and complete the step, and then go back and continue the presentation. Okay, if you're feeling overwhelmed, you could even rewind the presentation a little bit and watch the steps again and then continue.
Kind of like a hot dog bun. Then unfold it again and lay it flat. Now, fold down the top two corners. Try to line up each corner so that it reaches all the way to the fold in the middle.
As you can see, she's really pushing hard on the folds. That's super important. Push really hard and have nice, clean folds.
Now stop and take a look. So far, you should have a piece of paper that looks like a square at the bottom with two triangles on top. If that's what yours looks like, then let's keep going. Find the outer corner of each triangle and fold the triangle over so that corner touches the middle fold too. Now, close up your paper and flip it over. Fold down each side just about halfway to make wings. And you've got a paper airplane. Let's see how it does. That was pretty good, but how does a paper airplane fly? Well, it's all about forces. And in fact, the forces that help paper airplanes glide are the same ones that keep a real airplane flying high in the sky. A force is something that pushes or pulls on something else. And there are a couple of different forces that act on your paper airplane to make it fly. First, you need a force that creates forward movement. That kind of force is called thrust. In real airplanes, thrust is created by engines, which make the jet move forward by taking in a bunch of air and then pushing it out the back really fast. But our airplane is just made out of paper, no engines. So where are you going to get the thrust? That's right, from you. When you throw a paper airplane, you're providing the thrust by pushing the plane forward. After that initial push, your plane doesn't get any more thrust. It just glides, which is one of the reasons that it eventually falls to the ground. We don't just want our plane to go forward. We want it to float on the air. So we need another force to get our airplane flying high. This one's called lift, and it comes from the shape of the plane. Try making an unfolded piece of paper fly. It's hard. That's because the paper needs sturdy wings in order to fly. But when your airplane's wings slice through the air, they create lift. As your plane moves, the wings push air out of the way. But the air has to go somewhere, so it quickly gets out of the way by moving up and over the wing. And the faster that air moves over the wing, the less time it has to push down on it. So the air above the wing is pushing on the plane less than the air below it. This force makes the plane go up. A big airplane needs more lift to get off the ground than a small airplane. That's why bigger planes need bigger wings. Now, the plane that you and I made doesn't have a whole lot of lift because the wings are so thin. So in order to fly, this airplane needs a whole lot of thrust, which means you need to throw it hard. But there are lots of different ways to make paper airplanes, all with different shapes that make the most out of the forces that help them fly. So the next time you're looking for a fun indoor activity, just grab some paper and start folding. And if you come up with an airplane design that you're really proud of, send us a picture. And if you have any questions about anything at all, get an adult to help you leave a comment below or email us at kids@thescishow.com, and we'll see you next time.
All right, so just like she said, a super fun indoor activity, which is what we need right now, is making a paper airplane and throwing it with all the thrust and lift that you can. And that's what you are going to do today. It's a bird, it's a plane. These are the steps that you're going to do. One, you're going to plan and draw what you would like your airplane to look like on page 1, which is right here. But it's going to be in Seesaw, okay? So you open Seesaw and you plan what you want your airplane to look like. Step 2 is you grab a rectangular piece of paper and you fold the paper into an airplane. Maybe you already did that while the video was playing. Maybe you waited. I don't know. That's if you've already done it, skip 2 and 3. If you haven't, do step 2 and 3. So number 4, throw the airplane with as much lift and forward thrust that you can. Measure how far you threw it and label how far it flew on page 2 in Seesaw. Step 5, repeat step 5 2 more times. Sorry, repeat step 4 2 more times. So you're going to do 3 test throws. What I would like you to do is, before you do a test throw, I want you to practice. Just like Humpty Dumpty did with making the paper airplanes, you can practice throwing the paper airplanes. So practice and throw it as many times as you want. Then you can do your test runs, 3 of them. Make sure you measure the distance and add it to the chart each time. Step 6, add a picture of your paper airplane and make a video of it flying on page 3 in Seesaw. 7, add to your journal. There is also on Seesaw, there is a page where you're gonna, from your math book, where you are going to use the pencil tool or the text box to add in, where you're going to compare the distance of your 3 test flights. So, like I said, here is the make a plan page. Use the pencil tool to draw and design your paper airplane. You're going to test it out. How far did your paper airplane fly? Test 1, test 2, test 3. Write your distance in centimeters right here. This is the math page. So you're going to compare flight 1 to flight 2, 1 to 2, flight 2 to flight 3, and flight 1 to flight 3. Then last step is page 4, and that is you're going to take a picture of your paper airplane to share, and then you're going to create a video of you flying your paper airplane. And you add it right here. All right, well, that is it for this presentation, this video. Please go and complete your STEM activity on Seesaw. I cannot wait to see how far you throw your paper airplane using forward thrust and lift. Good luck.